what can we count or measure?
28.
Now let me get rid of this. That one else.
28 multiple choice.
Okay. So we got 28 multiple choice.
We can also kind of measure 70% of the choice. 70%.
Okay. So go ahead and underline 28. And that didn't work. All right, let's try that again. 28, 70% is multiple choice, and we want to know how many open-ended. Okay, so what kind of problem is this?
This is a percentage problem.
It's a percentage problem, isn't it?
Yeah.
Okay, so what kind of strategies did we use when we were dealing with percentage problems?
Diagram.
A tape diagram, didn't we? And that's the kind of day I'm having. I don't even know how it does that. I don't know
What was that?
I have no idea what I'm hitting to make it do that, but I keep doing it. And it's annoying me. Alright, so I got my tape diagram. I know 70%. So that means this piece is 30%. I know X is going to be 100% and Y is going to be one of the bottom two. All right, so if 70% of the test questions are multiple choice, do we know how many multiple choice questions there are?
Yes.
So where am I going to put that 28?
Under the 70.
Under the 70%. Good job, John. All right, now remember what we think is, and this is going to be X because that's always 100%. We always think to ourselves, Y is what percent of X? Okay, do we know Y?
Yes.
Yes.
We know that Y is 28.
But we don't know
Is means equals. Do we know what percent Y is?
Yes.
Yes, it's 70%. So we'll write that as a decimal. Of means to multiply, and we don't know X. So now do we have an equation that we know how to solve? So we're going to divide both sides by 0.7. And that's going to give us X equals 40. Now, what does that 40 mean?
that there were 40 open-ended questions.
No. It means
Look
there's
at
40
what the
total
picture looks like.
questions.
Oh.
This is open-ended. I'm sorry, this is multiple choice. This is open-ended. So what does that 40 mean, Max?
I was gonna ask what the code was, cause they kicked me out.
Okay,
I remember it.
CTW, ZQI. So this 28 is the 70%, right?
Yes.
The 40 is the whole thing.
Oh.
So how are we going to figure out the open-ended question?
Subtract by 28
So we're going to do 40 minus 28,
equals 12.
and that's going to give us 12. So there were 12
Open-ended questions.
open-ended. To read this problem, it's very confusing. But as soon as we underline and start drawing pictures, does it become clearer in your mind?
Yeah.
Yes? Because I agree,
Yes.
that's a very confusing to read question. But once I decided that it was a percent problem and knew that a tape diagram would probably help me, then it started to make a little more sense. Okay? That's the hardest thing about word problems, is figuring out what kind of problem it is so that you can pick the right strategy. All right, questions you still have for me about this one? All right, well, let's move on to our next thing. So So, today's learning goal is let's solve more complicated inequalities. So by the end of class, we are going to be able to write an inequality to represent a situation. We're going to be able to describe the solutions to an inequality by solving a related equation and then reasoning about values that make the inequality true. All right, so I picked one of the problems from the activities to go over. Karen has $100 saved in a bank account that doesn't earn interest. How much can he take out each month if he needs to have at least $25 in the account a year from now? All right, let's start out with what does at least $25 mean?
Meaning it has to be at least that
That's the
much
smallest.
or more.
Okay, so that's the smallest. So give me some values that we could have.
70.
70.
100.
100, okay? So anything larger than 25, right? Would 25 work?
Yes,
Okay, because it says at least.
that much.
Okay, good. All right, so this story is about
Money.
money in a bank account. What can we count or measure?
$100 at the end of the month.
There's $100 in the bank.
At least $25.
He wants at least $25 at the end of a year. Okay, what are we wanting to know? How much you can take out each month. Okay, so Claire comes along and she says, I'm going to write this in inequality to represent that situation. So what does X represent in our situation?
How much you calculate? Yeah, how much can you take out each month?
How much he can take out each month. And generally it is what the question is, okay? All right. Why do we have negative 12x?
I don't know.
Why is it negative 12x? If x is how much money you can take out each
Negative
month,
12. It's because that there are 12 months.
okay, there's 12 months in a year.
He
So-
says, and basically, never mind.
Okay, we got the 12 is because there's 12 months in a year. Why is it negative?
Because he's taking.
Because he's taking money out. Okay? So we're going to take that dollar amount and make it a negative because it's being taken out. Okay? Alright. What are some values of x that would work? Well, we could sit here and play guess and test, couldn't we?
Yeah.
We could make some guesses and test it. But we're not going to do that. We're actually going to solve it. But first, we're going to ask ourselves, would we use x is less than or equal to something, or x is greater than or equal to something? What do you think?
X is less.
Okay, I got to vote for less than or equal. Anybody want to bounce off that? I agree because, or I disagree because? Anybody?
I agree.
You agree? Why?
Because that if x is equal to or below, it means that he's taking out more than $12
Okay,
per month.
okay. Makes sense? Anybody else got a thought? All right, if you did the slides yesterday, or this morning, you discovered that the first step to solving an inequality is to turn it into an equation. Okay? All I did was put it equals whatever it said. I took out the inequality sign and made it equals. Now this is something you know how to solve, right? Yes?
Yes.
What if I drew it? Would that help? Understanding that the negative 12x really doesn't make sense on a, whoops, that's 100. And then over here, we have 25, hang on. So what am I gonna do first?
Take Take the 100 out.
Right, because we want to get the variable term by itself. Good. So I'm going to subtract 100. So now I get negative 12x equals negative 75.
And you want to divide?
Divide by
Negative 12.
negative 12. And I get x equals 6.25. Did I do it right? Did I remember it right?
Yes.
Check me. Okay. All right. That's 6.25 is what we're going to call the boundary number. Now, you told me, Kimberly told me we were going to use less than or equal to. And Makana agreed with her. So am I going to do an open circle or a closed circle? Does it include $6.25?
Oh, it's gonna be closed.
If I do exactly $6.25, I'm gonna have exactly $25 left, right? Okay, so it's gonna be closed. Now let's just reason our way through it. They said it was less than or equal to, but let's prove it on this, okay? If I take out $10 a month, plug in 10 here, what do I get? Negative 12 times 10 is negative 120. Add 100 to it. Negative 20. Is that greater than or equal to 25?
That is less.
That is not true, is it? That's not true. So I'm not going to shade this way. I generally pick the number 0, because if I plug 0 in here, what is negative 12 times 0?
Negative 12 times 0 is 0.
0. Is 100 greater than or equal to 25?
Greater than.
Is that true? Is 100 greater than or equal to 25? Yes. So that means I'm going to shade that way because 0 is over here somewhere. Okay, does that make sense? I liked your reasoning and I liked your reasoning. This doesn't make sense, what I just did?
Oh.
Did you say no? No? Okay. I'm not sure which way to graph. Let's say I didn't figure that out ahead of time. So what I do is I pick a value. All I've got graphed right now is my boundary number. Okay? I pick a value that's on one side and plug it back into the inequality. The easiest thing to pick is 0. Because when you multiply by 0, you get 0. So then all I'm left with is 100. So my question is this a true statement?
Oh.
If it's a true statement, then I shade towards 0. If it's not a true statement, I go the other way.
Okay.
Okay? All right, now, can I have negative numbers in this problem?
Yes.
Would a solution to this problem be negative numbers?
Yes. Yeah. It could be.
You can take negative numbers out of the bank?
Oh. No.
No. Okay? If all I gave you was the inequality, this is the solution. Any number less than or equal to 6.25 will make that true. But because we're talking about a real world situation, it's going to have some limitations. In this case, it can't go below $0. Okay? Make sense?
Yes.
Some other examples are if you're talking about people. Are we going to have half a person?
No.
No.
You can, but.
So your answers will be whole numbers. Okay? It might be greater than or less than, but it will be whole numbers. Okay? Shirts. Are we going to have half a shirt? No,
Yes.
we're going to have whole numbers. Okay? So those are some limitations when we're talking the difference between a mathematical problem and a real world problem. Questions you have on that?
Yeah, I just have a question.
Yeah.
So I was a little bit confused on, so you know when the part where you did, flow of x plus 100 equals 25? I was
Mhm.
just gonna ask, like, what happens if it wasn't like at least 25 and it was just that?
If it was just greater than, I'd
Would
still
you
make
still
it an
put
equation.
Would you still put equal?
Because what I'm doing is I'm taking that inequality, I'm turning it into an equation, solving it, and then I'm deciding which way I'm going to shade.
Okay.
If it says or equal to, I'm going to put a dot. If it says not, if it doesn't have the or equal to, I'm going to put an open circle.
Okay.
And then I'm going to pick which way I shade.
That makes more sense.
That makes sense?
Yeah.
Okay. All right, any other questions? All right, so I got something for you to do in a second here. So what are some ways we can determine where the solution to an inequality should use less than? What are some words that would be less than?
Less than.
Less than, what else?
Less.
How about if I said at most? I can have at most 20 popsicles.
Yes. Because you're saying that you can only have up to.
Up to 20, right. I can have less than 20, okay? How about for greater than?
Well, greater than, less, well. at
Greater than
least.
would work. At least, I want at least $20 in my pocket, okay? So I can have more than $20 and I'd be happy, right?
Yeah.
Okay, all right.
Hopefully you'll be happy.
Yeah. How can we tell if there are restrictions on the solutions? We just talked about that.
If it's real world or
People,
mathematical.
things, when it's real world, there's probably gonna be some restrictions on it, okay? All right. Name some values of x that satisfy that inequality. First off, what is that inequality?
The inequality.
What is that graphing?
Is, oh.
What's that graph?
Being less than 5.
Greater
Oh,
than
wait.
or equal to.
No,
I think it's
because
just greater
it was
than. It's just greater than.
Yeah, it's
Just
greater
greater
than.
than.
Because the
Just
circle's not closed.
Yeah.
Okay, x is greater than
5.
1.
I mean,
Greater than.
1.
1.
I don't know
Okay,
how to.
what makes it true? You did that because the 5 was right there.
Yeah.
What makes it true? 2, 3, 4. Does 1 make it true?
No, because the circle's not closed.
No.
Okay, good. How about this one?
It would be negative.
That would be.
That would be
X is less than negative 1.
Yeah.
Good. Does it include negative 1?
No.
No. Okay, it's any number that's less than. Could it be negative 1.01?
Yes.
Yes. Okay. Question? All right. Oh, Chris must have got kicked out. Put him back in. All right. Onward we move to practice problems. First
Is
one.
it okay if we write it on paper?
Yes, that's fine with me, whatever you want to do.
Okay.
Okay? All right, the solution to 5 minus 3x greater than 35 is either x is greater than negative 10 or negative 10 is greater than x. One of those solutions is right. Which solution do you think is correct? And be prepared to explain how you know. Okay, so circle which one you think is right, and then be prepared to explain why. Well, let me see what y'all come up with. You don't have to solve it if you don't want to. You should be able to reason your way through it. I'm telling you the solution is one of those two. X is greater than negative 10 or negative 10 is greater than x. Haley, there's not a negative 10 is less than X choice up there, is there? No, it's negative 10 is greater than X. Is that the one you mean? Y'all can circle the one. Alright, let's see who picked what.
Do you know how many properties are on the front? Again.
What?
Do you know how many properties are?
7. Alright, Coop, why'd you pick the first one? Why did you pick X is greater than negative 10? What's your thought process? Why'd you pick it? Are you changing your mind? Okay. Who picked X is greater than 10?
I did.
Me.
Akana, what do you think?
X is greater than negative 10 because that X has to be, you have to think that 5 is, oh wait, never mind.
Okay, Jahan?
Me, I said x is more than negative 10 because it would have to be a positive number to be more than 35. Because you're multiplying it by, wait, oh.
Oh.
Yeah, I just realized that. That's not a
Yeah, this was an issue we had on the test.
I got your own second guessing myself.
Is that multiplying it by 3 or is it multiplying it by negative 3?
It's multiplying it by,
negative 3.
no,
Negative 3.
it's multiplying it by 3.
Okay, so if I take a number greater than negative 10, give me a number greater than negative 10.
Greater than negative 10.
How about 0? Is that greater than negative 10?
Yes.
Alright, so 5 minus 0, is that greater than 35?
No.
Okay, so does it need to be greater than negative 10 or less than negative 10?
Less than.
It needs to be less than negative 10. This is really 5 plus negative 3x. So you need that negative times a negative to make it a positive. Okay, so you need something bigger than a negative 10 because your answer's got to be greater than 35. Okay, so the second one is the one that's true. Now, notice what's different about the second one.
The difference between the second one and the first one is because that if you, the first one is something under negative 10. So if you sit here, let's say negative 35, multiply it by,
So this one is saying x is this first one says x is greater than negative 10. So my boundary number is negative 10, open circle or closed circle?
open.
Open because it doesn't have an or equal to, okay? And then which numbers are greater than or equal to negative 10? Those numbers, right? Okay, this one says boundary number is negative 10. It has a greater than sign. Am I gonna go to the right?
Yeah.
What is this saying? Negative 10 is greater than x. I don't like it when the variable's not on the left-hand side for graphing, because to me that's thinking backwards. This is really saying x is less than negative 10. If I flip the inequality, I have to flip the sign. Okay? So read it to yourself. Negative 10 is greater than x is the same thing as x is less than negative 10. Okay?
Oh.
Make sense?
Yeah.
And that's why this one is the true one. Because 3 times 10 is 30, and you need something bigger than 30 for that second number there. All right. The next problem. If I get it to go where I can go to the next problem, you want to screenshot that?
Yeah.
Okay.
My handwriting sucks. This is really hard to write.
Problem 2. The school band director determined from past experience that if they charge $T for a ticket to the concert, they can expect attendance of 1,000 minus 50T. The director used this model to figure out that the ticket price needs to be $8 or greater in order for at least 600 to attend. Do you agree with this claim? Why or why not? All right, I'll give you about 2 minutes to figure out whether you agree and type in why or why not. Go. I agree or I disagree. What's the story about? What can you countermeasure?
It's about tickets.
Okay. What can you countermeasure?
$8
$8.
or greater.
Okay. At least 600. And then we have that equation or that expression sitting there, right? Yeah.
I was just confused. Where's
Hmm?
the 50?
I need a calculator.
There's no calculator in your desk? Grab one.
I'm just confused where's the 50 from.
All right, he's saying that that expression is gonna help him figure out the cost of the tickets. Okay? With T being, what's T representing?
The dots, how much money?
For each ticket, okay? So he's determined that that expression will give him what he should charge. And what he's saying is I should charge $8 or more if I want at least 600 people there.
So you just used a random number, 50?
No, that's the equation that he was given. That was based off of old sales. Okay, he came up with that. Okay? So what he's saying is, if I take that 1,000 minus 50T, that's what he was told is the model, okay? He wants to, they can expect attendance of 1,000 minus 50T if you charge T dollars. What does he want to show up? At least
600.
600. So what does that mean? At least is which symbol?
The greater than the
Greater than or equal to 600. Okay, now if we solve this for T, what's T representing?
how much money for each ticket?
Dollars.
Cost of
Each ticket.
each ticket, right? Okay, so if I solve this inequality, then I should know what I should charge for the ticket. He's saying he thinks it needs to be $8 or greater.
We do.
So now we've got to prove that it needs to be $8 or greater.
So are we gonna do what we did last time? 1,000.
So are we going to change this to an equation? Yes. Okay, what are we gonna get rid of first?
The 1,000.
Okay,
1,000.
what does that leave me on the left-hand side?
400.
Well, 400, negative 400 over
Negative
here.
400.
What about on the other side?
0.
50T.
50T or negative 50T?
Oh, sorry.
Negative 52.
Negative 50T. Now think about it, why has it gotta be negative?
Because
if
it
you
needs to
change
be
it to
addition.
addition, it's going to be.
Because it's basically saying 1,000 plus negative 50T.
Right, but also our answer needs to be a positive number, right? So isn't my unknown a negative number?
Yes.
Yes, it would.
Yes, okay? I mean a positive number because I've got a negative over there, alright? So now I'm gonna divide both sides by
Negative
50.
50.
negative 50.
Which is
What do you
eight.
get?
8.
T equals 8. So was he right?
Yes.
Yes, and if you think about it, if I take 50 times 8, what do I get? What's 50 times 8?
400.
400. 1,000 minus 400 is
600.
600.
Okay.
Okay, so does $8 work?
Yes.
Yes.
Yes. And we want, can he charge more than $8
Yeah.
and still get 600 people? Yes. Can he charge less than $8 and still get at least 600 people?
No.
No.
No, not according to the expectation in the sales. Okay? So you can do it this way, and I had somebody in second core just say, well, if I plug in 8 there, I end up with 1,000 minus 8 times 50 is 400. And does that give me the 600 that I want? Yes, so therefore 8 is my boundary number. Okay? Awesome. Questions? Have I confused you? Inequalities aren't any different than equations. The only last step you have is you're going to have to graph it on a number line. Okay? All right. Then let's move on to the next one. Which inequality is true when the value of x is negative 3? Go. I'll give you 2 minutes. Which of those is true when the value of x is negative 3? Yes, Rachel, of course it's okay. You'll get there. All right, let's see what I got people saying. Are you having a bad day, Max? You and Jeremiah have sad faces. It's Friday. How can you have a sad face? All right.
It happens.
All right, I'll give you another minute. Haley, are you having a bad day too? It must be the other Haley that has a sad face then. All right. All right, Simone, prove to me that A is a correct choice.
So, because A, I think is right, because negative 3 plus, negative 3 subtract 6 equals negative 3.5.
Ooh,
Because the negative and the positive is a negative, right?
okay, let me ask you, what does that mean to you? Does that mean the opposite of x? Negative x, the opposite of x? What is this saying? That's saying x is negative 3. So what number am I gonna plug in there?
Negative 3.
Am I? Doesn't that say to take the opposite
Make
of
negative
x?
before the x and regular x equals negative 3, so won't that make it positive?
Yes, that is saying 3 minus 6 is less than negative 3.5. Do you see why it's a positive 3?
Yes.
Think of this as not a negative, think of it as opposite. The opposite of x. Well, if x is negative 3, what's the opposite of x? 3.
Because that's
Okay,
saying it's
right, because it's going to be the opposite.
Because it's basically saying that that's positive x.
Mm-hmm. So is this a true statement?
No.
Okay, A does not work. How about B?
No.
No.
Okay. What is 3 minus 6?
Negative 3.
Negative 3, and negative 3 is not greater than 3.5. Okay. How about C?
Yes.
C works.
Yeah.
How about D?
Yes.
Okay, what do we put in
Yeah.
here for x? What do we put here for x?
Negative 3.
Negative 3 minus 6 is what?
Negative 9.
Is
So
negative 9 greater than negative 3.5?
No.
No.
Okay? So do we understand what the opposite of x and x mean?
Yes.
Okay? Be careful with that. Just because it has a negative sign in
Wait a
it.
second, please.
Yep, just because it has a negative sign in front of it doesn't mean that it's a negative number. Because if x is a negative sign, then the opposite of x is going to be a positive. All right. Okay, we ready to move on, Rachel?
Yeah.
Okay. All right, onward to problem number 4. Draw some solutions for me, go. X is less than or equal to 5 and x is less than 5/2, go. Thank you. Okay, have a good day. You too.
We all have to leave?
No, we're not done. We got 3 more problems to do.
Okay. I saw somebody leave. I thought
That was a teacher. All right, let's see what I got. Okay, first question. Am I drawing an open circle or a closed circle on 5?
Close.
Close.
Why is it closed, Coop? Because why, sweetie? No. What makes it closed? Kimberly?
Because that sign basically says less than or equal to.
Or equal to.
So it's included.
It's included. Good. Good thought. And it's included. So you should have a closed circle on 5. And it looks like everybody shaded in the correct direction. Okay. How about B? An open or a closed?
Open.
An open. And
It's
then
not-
5/2 is where?
2.5.
2.5, so we're gonna do an open circle in here, and then we're gonna go less than as well. All right,
Wait, no.
Yeah,
Yeah.
yeah.
x is less than 5/2.
X is
So if plug in 0,
Equal then
is
or
0 less than 5/2?
It's not equal then or less.
I'm sorry, what?
It's not equal then, less.
It's not less?
5/2 equals.
It would be
It
less
has to
than-
be
5/2 is how much?
2.5.
2.5, so I went 2.5. It was hard to draw.
Yeah, but
It's an open circle.
It's not equal then or less.
the sign
I didn't
would
make
be-
it equal. It's an open circle,
Oh.
Oh, that makes sense.
okay?
Yeah, that makes sense.
Okay, is it gonna go to the left?
Yeah.
If we
Yeah.
plug in 0 over here, is it true that 0 is less than 5/2?
Yeah.
Okay, so that's why we shade towards 0. Is that what you were questioning, or were you questioning the open circle, closed circle?
Open circle, closed circle.
I think we were questioning in positioning.
The position.
Oh, the 2.5?
Yeah.
Okay,
So
5/2 is 2.5, right?
Yeah, so 2.5.
My dot is way too big. It should be like right smack in the middle there, okay? And the way I would do that is I would write, there's that stupid thing again, okay? I would write actually 5/2 right there so that you would know, because it's hard to tell what the fraction number is, okay?
Okay.
All right, glad we cleared that up. Don't want you confused. All right, problem 5. Give me 3 equations that match that tape diagram. Go. Write me 3 equations. Remember, an equation has an equal sign, has an operation, a constant, a variable. Rachel got kicked out.
Mark, I thought I had it going again.
Did you get kicked out of Pear Deck too?
Yeah.
All right, here it is in the chat. All right, I'm seeing 19 plus 7x equals 40. That works. Can't draw on it. 19 plus 7x equals 40. I also saw 7x plus 19 equals 40. Why can I do that?
Because you
Because
divide
it's just switched around.
And
If you're
what,
adding, then you can flip it.
and what property lets me do that?
Commutative.
Yes, commutative. All right, now I need another one.
40 equals 7x plus 19.
Okay,
I did,
40 equals 19 plus 7x.
I
okay.
did 40 equals 7x minus negative 19.
Oh my goodness, yeah, that's true. I wouldn't have gone there, but that worked. How about 40 minus 19 equals 7x?
Sure.
That'll work.
How about 40 minus 7x equals 19?
That works.
That would also work.
How about that? And you can do Jahan's, what was yours, Jahan?
This 40 equals 7x minus 19, negative 19.
Yeah, we could go there. We could go there. All right, any other ones? Awesome. You want a screenshot?
Yeah.
Are we good? Okay. Goodness. That was interesting. All right, problem 6. A baker wants to reduce the amount of sugar in his cake recipe. He decides to reduce the amount used in one cake by half a cup. He then uses 4.5 cups of sugar to bake 6 cups. Cakes. 6 cakes.
He's trying to cook cups now.
Yeah, it's the end of the day. Describe how the tape diagram represents the story. All right, so what does the 4.5 represent?
The 4.5 represents the cups of sugar that I used to bake 6 cakes.
Okay, so that is that right there. How about that? All right. What does each of these blocks represent?
Each of the blocks.
It represents,
Each of the blocks represent how many cakes you made.
Okay, so each one represents a cake. Okay, so 6 blocks equals 6 cakes. Okay, what does X represent?
X represents how many of the other
how much he had, like, cause it says he wants to reduce, the amount of sugar.
So where does the reduced come in? Is that X?
Original?
So what is X?
X is the original amount of sugar used
The original amount of sugar used where?
in the cakes.
In each cake. There you go. X is the amount, the original amount. We'll squeeze that in there. Original amount of sugar in each cake. Okay. Now, why do we have X minus 1/2?
He's taking away 1/2 of the sugar.
1/2 of the sugar
Or
or half a cup?
half a cup of sugar.
Okay, if we took away half the sugar, wouldn't it have been 1/2 X? Okay, all right, see the difference? Okay, so this is reducing sugar by half a cup. Okay? I think we took care of all the pieces. Now they want us to figure out how much sugar was originally in each cake. Go for it. I'll give you a minute or two.
One and
1
1/2.
1/2,
Yeah,
okay.
it's 1/2.
I got an answer of 1 1/2.
Yeah, it is.
1 1/2 of what?
1 1/2 sugar.
Cups of
originally
sugar.
Used.
Okay, cups of sugar originally?
Yes.
All right, prove it to me.
Oh wait, what?
Prove it to me.
4 1/2 times 2 equals
4.5
9.
times 2. Why am I multiplying it by 2?
Because
Okay.
that's it was. Oh, this is 4.
How I got my answer of 1 and 1/2 is I multiplied 1/2 by the 6 cakes that he baked.
So 1/2 times 6 is going to
Which
give you,
equals 6.5.
No, it equals
No.
3.
That would equal 3.
okay, now what are you going to do with those
You
3?
minus 3 from 4.5.
Okay, are these already taken away? Is this really -3?
3, yes.
Okay, so how do I make -3 go away?
Make negative.
Don't I have to put those half a cups back in?
Yes.
Okay, because we're working backwards, we want to get back to the original amount. So I'm gonna add 3, aren't I? It's kind of like that eating the apple out of the bag. When you want to go back and find out how many apples were originally in the bag, don't we have to add the one that we ate?
Why are you?
Okay, so are we gonna add them back in? Yeah. All right, so if I add in 3 to 4.5, what do I get? 7.5.
7.5. And
Okay.
then wouldn't you have to divide that by 6?
Why would you divide that by 6, Rachel? Or was that Rachel?
Yeah, it was Rachel.
Okay.
I would, because that's how many cups there were in total for the 6 cakes, right?
Yep.
And to find out how much was in one cake, you would have to divide it by 6.
Uh-huh. So how much do you get for one cake?
I got 1 1/4. But
1 1/4 is correct. Okay? Mathematically, what is this equation? 6 times x minus 1/2, 6 groups of that equals 4.5. Okay, our first step is to get rid of subtraction. How are we gonna get rid of parentheses? I would multiply. I would distribute. Uh-huh. So you get 6x plus -3 equals 4.5. Ooh, isn't that what we did right here? See why it's -3? Okay, then we're gonna add 3 to both sides. So we get 6x equals 7.5, and then we do what Rachel said, divide by 6, and that gives us x equals 1 1/4 cups. So originally, each cake had 1 1/4 cups of sugar. So how much sugar is in each one now?
1 1/4 cup. Oh wait, a half a cup.
Now, how much sugar is in each cake now?
Half a cup is in.
No, it's
4
not.
cups.
No.
Wait,
How much sugar is in each cake now? This is originally
3/4.
3/4, uh-huh. You take 1 1/4 minus a half is 3/4.
Wait, say that again? I heard something.
Originally, we had 1 1/4 cups of sugar. Take away 1/2,
From what?
1 1/4, because
Oh,
x
okay.
is 1 1/4.
I thought you said 4.5.
No, 1 1/4. Take away half, and that would leave us with 3/4 of cups of sugar in each cake. Okay. Last problem. That's not a lot of sugar in a cake. Cakes usually have like 2.5 cups of sugar in them. All right, 1 year ago, Claire was 4 feet 6 inches tall. Now Claire is 4 feet 10 inches tall. By what percent did Claire's height increase in the last year? What's the story about?
Height.
Height. Okay, what kind of problem is it?
It's a percentage.
A percentage problem, okay? Do we want to use a tape diagram?
No.
No? Do we want to use a
Percent of
formula?
Percent of change.
A percent of change. Good, you recognized it as a percent of change. So we want to know how much the change is in relationship to what? The new height or the original height? The original. Everything is always based off of the original. So how much did her height change?
her height changed by 4 inches.
Okay. Now what are we going to divide it by?
The original.
The original.
All right, she was 4 feet 6 inches. So how are we going to divide that?
4 divided by 4.6.
Ooh, it's 4.64 inches.
Oh.
I mean, 4 feet 6 inches.
Oh, I mean, 4 feet. 12. You would do 12 times.
What if we just turned all of this into inches? 4 feet is how many inches?
48 inches.
48 inches. And then she had another 6. So how tall is she?
54.
54. So what, 9 divided by 54?
9 divided by 54 is.
9 divided by 54? I want 4 divided by 54.
Oh,
I thought you said 9.
I'm sorry.
I heard 9.
4.
13.5.
Like 7? 0.07.
0.07.
All right, is that a percentage?
Yes.
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 It's 7%.
I mean, you have to multiply it by 100.
There you go, that's what I was looking for.
My mind is.
It's scrambled.
You can have 0.07%, but that's not what it would be
Yes,
on the
I
calculator.
grew 0.07% last year.
Yeah. All right, questions?
I'm still writing.
Okay, I'll give you a minute.
I need more time.
I will give you a minute. Not a problem.
Just because you're tall doesn't mean other people are tall.
Who are you talking to?
I'm talking to Cooper.
I was gonna say, you're looking over this way and they're not tall over there. Power to the short people.
What were they doing?
I finished.
Okay. They were looking, she was looking to one side of the room, and on that side of the room were two short people. And she was talking about being tall or being short. It made no sense. Okay, next steps. Upload a picture of your work. In just a minute, I'll make it send you your copy of your slides. You have a quizzes today. Okay, not a Khan Academy, a quizzes today. You can take it as many times as you want. Goal is an 80%. You have a check-in and a reflection. And of course, you've got Imagine Math. Lesson 15 slides and activities before Monday. I should have those up by this evening. And if you want to do error analysis with me today, I will be on Zoom at 5 o'clock.
Don't forget the.
And now I can turn off the camera. All right, y'all have a great weekend.
Bye.
Bye.
I'm sorry.